Hello guys, in this video I will explain cache and persist concept in Pyspark. So this is a theory lecture. In this lecture we will discuss what is the scenario when we should use the cache and persist, how they are working internally, and what is cache and what is persist. In next video we will write Pyspark code. So this is the theory lecture. Next video will be practical. So let's now start. To understand what is cache and what is persist. To understand cache and persist, we should understand one scenario. When should we introduce this cache and persist? Let's think you are creating one additive. So let's think you are creating one additive by doing bunch of transformation. Okay. So first what you doing? You are getting additive one, doing some sc.text file. You are loading the file. Then you are doing some rdd2 sorry rdd2 equal to rdd1 dot some transformation you are doing, some transformation you are applying here. Again you are getting rdd3 on top applying some transformation on top of rdd2. Again you are applying some transformation. Again we are getting rdd4 after applying some transformation on top of rdd3. Like this we are getting rdd. Now at last we are getting rdd5 and we are using some transformation on top of this rdd4. So now we we now rdd5 is our final result. Okay, so let's understand this thing. To get this rdd5 we are doing this bunch of transformation. Am I right or not? We are first loading, then we are applying this transformation here, we are applying transformation here, we are applying transformation here. So to get this identify, we are applying, we are doing bunch of transformation. Now, if I want to use the value of this identify in our code multiple times, then our what is will be what is will be what is will be our thinking process. Like if I want to use this identify value in our Pyspark code, many times, then what I can do? So one thing we can do, we can store this RDD5's value in our memory and then you can use it. Otherwise, every time we can calculate this RDD5 when it is required. So the efficient approach will be to store the RDD5's value in some memory so that we can use this RDD5's value again and again in our Pyspark code. So from this concept, from this like approach we are introducing. So this is the scenario where we are introducing cache and persist logic. So what actually you are doing? So we are getting RDD1, then we are getting RDD2, then we are getting RDD3, then RDD4, then RDD5. Now let's say we are doing print rdd5 dot collect. Collect is a action. When you are calling action, it will try to execute all those. It will try to execute our Pyspark code. Means it will see the tag and then execute all those transformation. Then again, I am what am I doing? Again, I am trying to do print rdd5 dot collect rdd5 dot count. So count is also action. So in our Pyspark code, single Pyspark code, we are using two time action. So for every time, for collect, for also count, this whole process will execute. So first for count, for collect, first our Spark engine will try to get RDD1, then it will get RDD3, then RDD4, like this. For count, when you are applying count action on RDD5, to get this RDD5, Spark engine will execute this same process again. So we are doing repetitive work. To save to avoid this repetitive work, what we can do, what we can do, we can create this, we can create this RDD5 like this. RDD5 equal to RDD4, sorry, RDD4 dot cache. So we can do like this. When you are doing like this, when we are doing like this, it means we are storing value of this RDD4, like value of this RDD5, we can say inside a memory, it means RAM, so that we can use these RDD5's value again and again. Now when we'll applying some transformation or applying some action on top of this RDD5. So let's think we are applying cache here. Okay, so cache is done. Now we are applying some transformation on top of RDD5, some transformation we are applying here. Then again we are doing some action, print RDD6 dot collect. So we are trying to using this collect action. Now when we will hit action here, our Spark code will not execute. So let me write another action, print, like if I say RDD6 dot count, let's see, this is a count, COUNT count. So there are two action, one is collect, one is count in our Pyspark code. And here we are using RDD5 equal to RDD4 dot cache. Now when my Spark engine will hit this collect action, fast action, it will try to execute this process from RDD1, then RDD2, then RDD3, RDD4, then RDD5. Okay, when it will come here, it will try to store the RDD5's value inside in our memory, in our RAM. Now it is printing some, then it will try to transformation here. Then when we are meeting this action collect, it will try to print the RDD5, RDD6 value in our console. Now again now it will come to here Spark engine, the pointer should come here. Now what we are doing RDD6 dot count. It means the count is also action. When we are hitting when we are when Spark engine is hitting any action again, the calculation, the execution process it is not it is not like that. It will start from this RDD1. It is only it will start only from this RDD5, from cache value. So Spark engine will try to compute value from this RDD5. Okay, then it will try to print the count of RDD5, how many number of record is there. So because we are already stored our RDD5's value inside memory, that's why Spark engine will not execute, will not calculate this RDD5's value again. It will try to get the RDD5's value from this memory, and then it will do something transformation here, then it will try to print. So that is the logic behind it. Okay, so when we are using cache, it means we are trying to storing our intermediate RDD's data, RDD value inside memory, so that we can use those value later in our Pyspark code. So cache and persist is same. Okay, the working of this cache and persist is same. This is same. Okay, so if we are calling this RDD5 dot cache, equal to RDD 6 or RDD 6 is equal to RDD dot persist. So this cache and persist will do same thing when we are not passing any argument inside persist. Without argument, persist and cache is same. No, there is no difference. But if we pass some parameter inside this persist, there will be different. Okay. Actually, they will try to save the result, but where they will save, that is the matter. Okay. So if you want to reuse the, now I will try to make some point here. So if you want to reuse the results of existing RDD, then and you can use persist and cache. Okay. So this is the main point. So going to reuse. And but what is the difference between cache and persist? So both is for same purpose. Cache and persist both have a same purpose. It will try to store the result. But where? That is the difference. So difference between cache and persist. Okay. So cache, if I use cache will cache RDD in memory. Okay. In memory means in RAM it will try to cache our RDD. When I am using RDD 6 equal to RDD 5 dot cache, it means the RDD 5's value will try to, so that means we will get RDD 6 and the value of this RDD 6 will be inside in a memory when we are using cache. But when we are using persist, RDD 6 equal to RDD 5 persist. So this persist comes with various storage level. Let me drink some water. However, persist comes with various storage levels. That is the difference. Cache is comes with only in memory. So cache will store result inside memory only. That's it. But when you are using persist, it will give us option. So where we want to store our result in memory or in disk or off in memory. So the option will be various storage level. So what is the various storage level? One, it can be in memory. In memory means RAM. Second, it be in disk, hard disk. Okay. Other is off heap memory. Off heap. Okay. So persist come with these three storage level where we can store our result, but cache comes with only in memory. Okay, that is the difference. Both are doing same thing. Both are doing storing the result, but persist provides us many options where we can where we want to store the result, but cache comes with only one option. It means in memory or RAM. Okay, sorry for my bad. One thing I want to write down. Want to write down here. Persist. This is very important thing. Persist without argument. Argument is equivalent to cache. Okay, you should remember this. If I don't pass any parameter inside this persist, it will be same as cache. Okay, and this persist means without any parameter argument, this persist will store or persist result in memory like cache. Okay, so if we don't pass any argument inside this persist, it will act like cache and it will store the result, the value of that RDDs inside in memory like cache. Okay, now what type of argument we can pass or parameter we can pass inside this persist method. Okay, so persist transformations, persist we can pass this persist like storage, you can pass like this. Let me write here storage level dot disk only, so it will store in our disk only. Another way you can do persist memory only, memo or memory only. Okay, so memory only, it means we have to like pass this one storage level dot memory memory only. So like this we can pass the argument inside persist method. It means persist transformation inside this means it will store the RDD's result inside disk and it will store the RDD. This means it will store the RDD result inside memory in memory. Okay, inside RAM. So when you are storing, there is two concepts. So you can store our result in serialized mode, serialize or deserialize. Deserialize. I hope you know what is the meaning of serialize and deserialize. Okay, so you can store our result inside memory or disk using these two methods. Okay, in this using these two techniques. So when I am saying serialization means it is in bytes format. Okay, you should remember this thing. Serialization means serialization is in bytes format. So it will take less storage. And deserialized means, I mean non-serialized. Say non-serialized or deserialized, what you want to say, means, so you can store serialized or non-serialized, not deserialized, serialized or non-serialized form. So what is the meaning of non-serialized means? We will store value of RDD in object format. Okay, in object format. Okay, when using or object format means it will take more time. When you are storing in object format, it will take more time. You should remember this. When you are storing in bytes format, it will be what? It will take less time. So it will take less storage, not less time. Okay. So when we are storing object in object format, it will take less time, but it will take more space. When you are storing in serialized mode, in means bytes format, it will take less time, sorry, less storage, but more time. That is the thing. Now let me write all those options, all those arguments name. What you can pass that storage level, what you can do, you can pass this disk only. This is our serialized, okay? Serialized. Serialized. So when you are using disk only, means this is the serialized format, okay? So it will try to, so Spark will try to uh, persist. The persist means store, okay? You can say, so persist the data inside disk in serialized format. It means in bytes format. Memory only means by default, when it is memory, it will be a non-serialized format, okay? By default, non-serialized, it means in object format. We'll try to store this value in object format. Serialized. When we are storing something in object format, it will take what? It will take what I can say, more space, but it will be faster. Okay. If I use this option, memory and disk, so by default this is the non-serialized, okay, non-serialized. Of if this is the another like another parameter, another argument we can pass. Of if this is serialized, memory only, let us say here it means when you are seeing memory only, it will always try to store our value of identity in a non-serialized format, means object format, but using this memory only SCR, it will try to store our identity value in serialized format, okay? This is serialized. This is serialized, okay? Serialized. Memory. and SCR is serialized. This is serialized. Okay. So now I wrote down all options, all parameter what we can pass inside, all options what we can pass inside persist transformation. Now I will try to explain you what actually this this disk only. So what actually this optionality. So when you are saying disk only means it will try to the Spark will try to store the RDS value inside disk hard disks. Okay, in serialized format it means in bytes format. When you are using in byte format means it will take less time, less storage. Okay, that is by default non-serialized. Okay, memory and disks. Memory and disks means see fast the Spark engine what Spark engine will try to do. First, it will try to cache the data inside our memory. When you are seeing memory and disk, it will try to store the data inside memory also inside disk also. Let's say our like RAM is 2 GB. Okay. Now I want to store and to cache our 3 GB, 3 GB, 3 GB data. I have 3 GB data. I want to cache this 3 GB data inside this RAM. I cannot do that. Okay. So what I can do, I can so it will so Spark will try to speed this data. Okay, so it will try to cache 2 GB data here. Okay, because 2 GB data can fit inside this RAM and another 1 GB inside hard disk. Okay, so that's how this memory on disk is working. So data is cached in memory. If enough memory is not available inside our if enough memory is not available inside RAM, you can think then evicted blocks, then remaining other blocks which are not fitting it in this memory, the evicted blocks from this memory are serialized to disk. Means those parts of data which are not able to fit in into this RAM because due to some storage issue, it will try to fit into inside disk. So first, Spark will try to store all the data in inside RAM because of some like limitation of storage here. Some data will store here, some data will store here. That is the our memory and disk, and it is a non-serialized. It means it will try to store our mm, data in an object format because object format is faster. When you are storing the any data in object format inside a RAM, it will take more spaces than serialized format, but it will be more faster. So, and this process called block evaluation process. Okay, it means Spark will try to store some data inside the RAM, and if if some data is not fitted into into this RAM due to limitation of storage, remaining data will be stored in this on the hard disk. So this is called block eviction, block block eviction. Interviewer can ask this question, very important question. Eviction. Okay, what is block eviction? They can ask. So we will just explain this thing. So Spark will try to fit some store. Uh, Spark will try to persist some data inside memory, but due to limitation of that storage inside the RAM, remaining data will store inside our hard disk. Another parameter is off if. Okay, it is just serialized. It means it is just by default it is just serialized. What is this of heap memory? Of heap. So when we are saying RDD 5 dot persist persist storage level dot of heap. what is the meaning of means? What is the meaning of this? When we are saying persist, and under this we are passing this parameter. What is the meaning of this? Of if, of if. What is the meaning of this? Of if means blocker cast in of if. What is the of if? Of if means outside the JVM executor. So you can see this is our worker nodes. This is our executor there EX. Okay. So of if means this area. Okay. Outside of this executor. Executor means some JVM. Okay. So outside this JVM, this executor, it will try to giving a piece of raw memory and it will try to store the result of this activity. So Spark engineer what will do? Will try to Spark will try to store the value of this activity outside this executor, and it will try to grab some memory from this worker node, some raw memory outside this worker node, outside the executor, and it will try to store outside this executor. Okay. Okay, that is called off memory. But problem, but what is the problem is like storing inside this executor, or in executor we can say executor equal to JPM. Okay. Okay, I already explained this thing. Okay, you can go through my video. So JVM, so but because the JVM is using garbage collector. Okay, for freeing up that the memory. So storing, so that is the issue here. So storing object outside JVM in our memory so that we don't have to call garbage collection. That is the important thing. So I will try to write here. So garbage collection is to free up the space. So so what I can say, if I storing the memory inside this executor. So executor in means JVM uses this garbage collector to free up the memory spaces. But calling this garbage collector is a time taking process. Time taking process. Okay. That's why we should store the result outside the JVM. It means off if. This is called off if. So that we don't have to call garbage collection. And we can save our time. But off if is a unsafe memory. Okay. We should not do this. Storing inside this executor is safe, but storing outside the executor is unsafe. But when you are storing, so there is a pros and cons. If I storing data inside executor, it is safe, but it will take more time to free up the spaces. But if I store outside the JVM means outside the executor, it will be faster. It means uh, we don't have to call the executor to free up the paces, so we can say it means we will save a lot of time. But storing outside result outside JVM is unsafe because we are dealing with raw memory. Okay, that's it in this video. Before ending my lecture, I will again explain this block eviction. Okay, because this is very important, because interview can ask this question. Eviction, TION eviction. So I'll try to write. You just noted down this block eviction thing because interview can ask. Very important. Consider the situation that some of block partitions are so large, means skew, okay, that that they will quickly fill up. storage for caching. Okay, you means consider the situation that some the block partitions are so large in queue that they'll quickly fill up storage memory for caching. In this case, what you can do when when storage storage memory becomes full, and eviction policy will be used to make a space for new blocks. Okay, this is called LRU. 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 It means, so let's say, uh, how can I explain this? So we have stored some value inside our memory, and so, but when we are to try to store the partition inside our memory, so that because of some limitation issue of that, like storage limitation of that RAM is filled. Now think in our in memory we are trying to store all those partitions P1, P2, P3, P4, and try to cache all those partitions, and it's become full. Now we not able to store the we not able to cache other partitions. Now what the Spark will try to do? It will try to find out the least used partitions. So it will see which partition we are not using, which partitions we are not using. It will see this we are not using this P3 partition. So the Spark will try to evict this P3 partition, and it will try to store our inside hard disk or disk. So it will try to evict this P3 partition from here to from memory to from RAM to disk, and then in that place it will try to bring new partition and it will store here. To do this, we are following this LRU scheduling algorithm. I think you know this what is this LRU, because we already studied this LRU in our college days. Okay, list recently used scheduling algorithm. So that's it in this video. Eviction policy is very block eviction is very important in prospective interview, and I already explained those persist and cache and what is the difference and when you can use this. Next video I'll write code for for cache and persist, how you can write, how you can implement this cache and persist in in your Pyspark code, and I'll give you a practical demo. So that's it in this video, and I am looking for data engineering entry level jobs. Currently I am working as a C++ developer, but I am looking for data engineering jobs. So if you have any opening in your company, please refer me. You can find my LinkedIn ID below in this video. That's it. Thank you for watching this video. Bye. Have a good day.